And now I'm going to do another analysis by going to compare means. That's a basic tool that you can use to compare groups. For example, if I want to see if boys and girls perform differently in different courses, I go compare means and choose independent sample t-test. And here I choose the courses that I want to compare first by dragging them here, and then I put like gender here to to tell the program that I want to compare male and female. And then as you see, I get a question mark here asking what are the numbers I use for different gender. I use 1 and 2, and I put 1 and 2 here, click OK, and now this table is a simple t-test comparing boys and girls. Now as you see here, I have the f value, the t value, and the mean differences, and the level of significance. So you see we have 0.000 for the first variable, that's physics. So in physics there is a significant difference. Anything that's less than 0.05 based on what we learn in statistics is significant. So physics is significant, chemistry is not significant, math is significant, pre-test is not significant, and post-test is not significant. And also it's interesting to look at this table that shows the average for male and female, and that shows that male are significantly higher than female in this example. Now the other thing that we use a lot is correlation. Correlation we use when we want to see if there is a relationship between two variables. So I go to analyze, and then I go to correlate, and I choose bivariate because I have two variables, and now I can use just a pair, like a pair of variables like physics and chemistry, and click OK. Or I can put the whole thing here because it gives me all correlations in one table and it's easy to see. So I choose this and put it here and click OK. Now I can see the correlation. For example, the correlation between physics and math is 0.74, and the correlation between physics and pretest is minus 0.24. So you can see how big are the correlations between different variables. And the ones that are significant, statistically significant, are shown by asterisks. If you have 1 star, it means that it's significant at 0.05 level, and if you have 2 stars, it's significant at 0.01 level. The other thing that you need to do most of the time is comparing more than 2 groups. So in the first example I compared male and female, but if I want to do, if I want to compare different ethnicities, I can't use t-test anymore. So instead of going here and choosing independent t-test, I use one-way ANOVA. That helps me to see that if there is a significant difference between different ethnicities. Okay, so ethnicities goes here, okay, and the other variable goes to the dependent variable list. Okay, also I can choose, you know, what type of post hoc analysis I want to do, like LSD or Tukey. These are the popular ones, and I can choose you know, as many as I want, and I can also choose the level of significance And here are more options. For example, if you want to include descriptives, you choose descriptive and you click continue and click OK. And as you look at this example, 0.93, 0.15, none of them is less than 0.05, so there is no significant difference among different ethnicities, so we don't have to be worried about this. But if we had a significant difference, then we had to go to this post hoc test and see, which one or which pairs are significant. Like for example, if you have an overall significant difference, then you have to see, is this the difference between Asian and Latino, or the difference is between white and Asian. And finally, the last thing I want to show you is a different type of t-test that we use most often, and that's the difference between pre-test and post-test. So you evaluate the same people, the same participants twice, and you want to see if there is a difference between the first measurement and the second measurement. If you want to do this, you have to go to compare means again, and this time choose paired sample t-test. Paired sample t-test is for pre-test and post-test. You move the pre-test to the first column and the post-test to the second column, and then you click OK, and that shows the mean for pre-test and the mean for post-test, and the analysis shows that the difference is significant because this number here is less than 0.05. Before I finish this tutorial, I gotta show you something that's very important. A lot of time you have to create new variables. For example, you have mother's income and father's income, and then you want to add them to calculate the family income. Or you have, like in this example, you have student score and you want to calculate the average. Any calculation you want to do, you gotta go to transform and then choose compute variable. Okay, so for example, if I want to calculate the GPA, I type GPA here, and then I put the equal sign is already there, and all I have to do is choose the courses that I want to take the average of, like physics plus math plus chemistry divided by 3. This is how you calculate the average. You can type the equation, or you can choose one of these options that you have that gives you pre-made statistical analysis or logical calculations. So you put GPA, the new variable, here, and then you click OK, and as you see in the output, nothing shows up. But if you go back to your data, you see a new variable is created that shows the students' GPA in physics and chemistry and math.